So REDOX is an acronym which means reduction and oxidation. So they are joined together, and you'll be asking what is the reason behind joining it together to make it redox. So the reason is that reduction and oxidation are both reactions that occur at a particular time. They occur at the same time. For example, reduction can't occur without oxidation. So whenever oxidation occurs, reduction will also occur. So from time immemorial, people have been given different definition of redox reaction. Redox reaction was defined in terms of removal and addition of oxygen. It was also defined in terms of removal and addition of hydrogen. But currently, the definition in which everybody accepts is in terms of electron transfer. But let us look at in terms of oxygen what it's saying about. So in terms of redox, in terms of oxygen removal and addition. So reduction is a reaction in which oxygen is being removed from a particular compound that contains oxygen. That is in terms of oxygen. So for example, in a reaction where oxygen is in a compound, so if that oxygen is being removed, we will term it reduction. Whereas in, okay, let me write it down. So reduction is a reaction in which oxygen is being removed from the substance, whereas oxidation is a reaction in which oxygen is being added. So this is a reaction So any reaction that involves addition of oxygen was termed to be oxidation, while the one in which oxygen was removed was termed to be reduction. For example, in a reaction like this, in a reaction where copper 2 oxide reacts with hydrogen to give us copper on its own and H2O, which is water. So in this reaction, if you remember, I told you that oxidation and reduction, they occur at the same time. We shall be seeing it also in this reaction. So here, copper 2 oxide turned to copper, whereas hydrogen turned to H2O, which is water. So from copper 2 oxide to copper, what was lost is oxygen. So because of oxygen was removed, it's going to be reduction. And because of oxygen was gained, or oxygen was added to hydrogen, this is going to be oxidation. So this is just it. Redox reaction in terms of oxygen addition and oxygen removal. So, but we shall not dwell on this. We will be talking about redox reaction in terms of electron transfer. So redox reaction in terms of electron transfer. So it's a kind of confusing, but once you understand how the mechanism work, you'll be able to, it will be a cakewalk to you. So redox reaction in terms of electron transfer, reduction means a reaction in which electron is being gained. A reduction is a reaction in which electron is being gained. For example, okay, let me write it down first. So if reduction is a reaction in which an electron is gained, then oxidation will be a reaction in which an electron is lost. Let's also write it down. So this is it. Reduction is a reaction in which electron is being gained, while oxidation is a reaction in which electron is lost. And we'll be using a reaction in order to cite an example for us to learn more and understand more. So just copy this thing down and so iron 2 chloride reacting with chlorine in order to give us iron 3 chloride. So in this reaction, the most significant or fundamental element in which we'll be checking where the transfer in electron occurred is ion. So we'll be checking this and this, and from here already we've been told that this iron 2 chloride and this iron 3 chloride. So iron 2 chloride has this ion, whereas this has this ion. Okay, so here we have iron 3 and here we have ion 2. So what happens in this reaction for this thing to change from ion 2 to ion 3 is an oxidation reaction. This is an oxidation reaction. Don't get confused. I said oxidation is when electron is being removed, and you'll be asking yourself that why is it that electron was removed but this thing we still have 3. You know, on normal, when something is removed, the number is supposed to be lower, but I want you to understand the fact that electron has a negative charge already. Electron has a negative charge on its own. Electron has a negative charge. So if electron has a negative charge, it's going to affect the process. For example, now let's just say we have 2 here. Let's bring down the 2 we have here. We have 2. Then 2 minus electron, because of, let's just use one electron now, will give us, remember, minus times minus will give us addition. So 1 plus 2 will give us 3. So the thing that happens is not about the product, it's what happens in the process. It's what happens in the process that matters. For example, now we have electron. Just know it that electron is a minus sign. So because of electron is a minus sign, minus this minus this will give us addition in order to increase this number. But what happens in oxidation is what electron was lost. So that electron was lost has already been shown by giving us this minus sign. So that is it. Then in this, sorry, then what happened there is what is reduction from chlorine 3 to chlorine 2. So this is it. Then in order for you to understand this thing the more, I would like to explain how we found this to be 2 ion. This ion. So what one thing you're supposed to understand is that when we have a compound, for example, we have iron 2 chloride. In iron 2 chloride, they have reacted together. Iron and chlorine has reacted together in order for us to have iron 2 chloride. So when element and element react, they don't react on a neutral stand. Don't react. For example, now sodium like this is neutral, chlorine like this is neutral, and because of it is neutral, the charge in which is going to have, which is also the oxidation number, is going to be 0. They don't react this way. So in order for them to react, for example now, for sodium to react with chlorine, they have to be an ion. You understand? They have to be an ion, and that in whatever the ion they have, the ion number in which they have gives them their oxidation number. I will still come to that. So looking at this, we have ion 2 sodium chloride. I want to show you a way in which I found out that this is 2. So we will solve it this way. So we had ion so remember what we are looking for. We want to know the number of ion in which this ion bears. The number of ion. Remember we said it was Fe2 plus. So we want to confirm how it is Fe2 plus. So one thing you're supposed to understand is when solving something like this, we always equate this compound to 0. For example, we do it this way: 2FeCl2 equal to 0. Then remember also that these two will multiply this and this, whereas these two will multiply only chlorine. So in solving this, we now say 2. We are looking for ion times Fe. Then there will be an addition plus. We will now get the oxidation number of chlorine. The oxidation number of chlorine is -1. So plus -1 times 2. These two will times the oxidation number of chlorine. Then equate it to 0 also. So here we have 2Fe. 1 times -1 times 2 will give us -1 times 2 will give us -2, and plus times minus will give us minus. So we're having -2. Sorry. So remember I said that because of these two is bold this way. So these two will multiply everything here. So these two multiplying everything here will make this to be 2 also. But originally the oxidation number of chlorine is -1, but because of these two, so 2 times -1 will give us -2. You understand? So in order for us to solve, we have 2 Fe, then -2 times -2 times 2 will give us a -4. Then this plus times minus is also will make this minus to stay. This minus will not change. So we have 2 ion -4 equal to 0. You understand? Then we make this the subject formula by equating it to 0, and this -4 crossing over will be +4. So what we'll be having is 2 ion equal to 4. Then in order to make ion the subject formula, we divide everything here by 2. When we divide everything by 2, we'll be left with F equals to 2. So that is why we have this. We have the ion here as ion 2 ion. So this is it. So you understand this in the more when we solve for oxidation number. So we'll be talking about oxidation number. So oxidation number is a combining charge in which an element bears when it is in a combined and uncombined state. For example, now we have sodium on its own. When sodium is on its own, is uncombined, is in an uncombined state. But when we have sodium chloride, you see that sodium is in a combined state. Okay, something like this. So this is it. When it's a compound, we have sodium chloride is in combined state. So we see oxidation number is a charge in which an element bears when it is in a combined or an uncombined state. So there are rules in which we use in getting oxidation number of different elements. So these rules, I shall run it down. The number 1 rule says that elements that are in an uncombined state has the oxidation number of 0. Yes, it has the oxidation number of 0. For example, I'll use sodium has the oxidation number of 0. Chlorine has the oxidation number of 0. Oxidation number of 0. All these have oxidation number of 0 because of what? They are in an uncombined state. Had they been combined, they wouldn't have had 0 as their oxidation number, but because of they are on their own, they are not combined. That's why they have oxidation number as 0. Then the second rule The second rule states that when you have an ion, the number in which that ion bears, the number and sign in which that ion bears, will still be the same oxidation number of that ion. You remember what an ion is? Ion is an atom that has been charged. For example, now we have aluminium. We have aluminium to be 3+. Because of aluminium is 3+. Because aluminium is 3+. So the oxidation number of aluminium ion is going to be +3. So that is how it works. So if the oxidation number of sodium happens to be +1, then that is for sodium ion. Then for this the oxidation number of sodium ion will be equal to +1. So that is the second rule. Then the third rule states that when we are solving for a particular oxidation number in a compound, that every compound is equated to 0. I'll use sodium chloride also as an example. So had it been we have something like this, and we are looking for, we don't know the oxidation number of sodium, but we want to find it, that this compound is going to be equated to 0. The oxidation number of oxygen in a combined state is -2, but when it is in peroxide, it's going to be -1. Then for hydrogen, the oxidation number is going to be +1, but when it is a hydride, it's going to be -1. So oxygen is going to be -2, but in peroxide it will be -1, whereas hydrogen will be +1, but in hydride it will be -1 also. So we'll be using the rules I just gave in order to solve for oxidation number of a particular element in the following compound. So in this compound, this tetrazosulfate acid, we'll be looking for the oxidation number of sulfur. So looking for the oxidation number of sulfur. So let's solve. So just note that this tetrazosulfate acid, and we are looking for the oxidation number of sulfur. So look at how to solve for it. We have the compound to be this H2SO4. So there's, I think, the third law. I told you that all compounds, when you are solving for this, will be equated to 0. All compound will be equated to 0. So let's equate this to 0 now. Now equating these two to 0, what we are going to do is oxidation number of H2 plus X that we are looking for. We are looking for oxidation number of sulfur, then plus oxidation number of oxygen multiplied by 2. So I multiplied by 4. We are multiplying by 4 because of this 4 here. So this 4 will be multiplied by the oxidation number of oxygen. So already from the law we gave, oxidation number of hydrogen here is going to be plus 1. Then because of these 2, we plus 1 times 2 plus, we're looking for sulfur, so we write it X, then plus, then the oxidation number of oxygen, as I stated before, is going to be minus 2. So we'll be having minus 2 times 4 because of this 4. You equate this thing to 0 also. So minus 1 times 2 will give us 2 half plus X half plus minus 2 times 4 will give us minus 8 equal to 0. So move over here. So we have 2 already plus X, which is sulfur. We are solving for the oxidation number of sulfur plus. So here plus times minus will give us minus. So this place is going to be minus. So we have minus 8 equal to 0. You have to solve for X. We make S the Soviet formula. This X, we equate it to 0. Then this coming over will be plus 8, whereas these 2 moving over the equality sign will be minus 2. So sulfur will be 8 minus 2 will give us 6. So the oxidation number of look at it. We solve one more example. The oxidation number of sulfur in H2SO4, which is tetraoxosulfate acid, is 6. So we solve one more example. In this compound, let me just be using oxidation number as well. And what is it? Oxidation number of chlorine in this compound. We are looking for the oxidation number of chlorine in this compound. And also oxidation number can be used in order to name a compound. For example, now we have this is supposed to be potassium triosochlorate, then a figure. So now for us finding chlorine, it will give us a hint on what that number should be. For example, now let me just write potassium Okay, so in this compound, we're looking for the oxidation number of chlorine in this compound. So oxidation number also can be used in order to name a compound. I'll also show you, but let's just solve for chlorine first in this compound. So here the oxidation number, remember the oxidation number of chlorine. Okay, the first thing you do, equate it to 0. Now the oxidation number of potassium is plus 1. When you put addition sign, we are looking for chlorine, addition, then oxidation number of oxygen in a compound, if you remember the rules I gave you, is minus 2. So it's going to be minus 2 times 3. This 3, you equate it also to 0. So here we have plus 1 plus chlorine plus minus 2 times 3 is going to give us minus 6. Put it to 0. Then we will now have plus 1 plus chlorine minus 6 equal to 0. Because of plus times minus will give us a minus, and that's why we have this negative. That is why we have this negative sign. So making chlorine the subject formula, chlorine being on its own equal to 0. This 6 crossing over the equality sign will be plus 6, whereas plus 1 crossing over the equality sign will be minus 1. So chlorine will be equal to 6 minus 1. 6 minus 1, which is equal to 1. So in this compound, chlorine, 6 minus 1, which is 5. 6 minus 1, which is 5. So in this compound, chlorine has 5 as the oxidation number. So now if you are to name this compound, it's going to be potassium triosochlorate 5. Potassium triosochlorate 5 because of this 5. So let's also try with another example. Here we have H and O3. So let's find the oxidation number of nitrogen. In this compound. So here in this compound we have hydrogen, we have nitrogen, and we have oxygen. And here we apply the rules in which I gave you. I said here this is not a hydride, neither is it a peroxide. So hydrogen is going to be having plus 1 as an oxidation number, then plus N, which we are looking for, plus minus 2 times 3. put everything to 0 also. Have plus 1 plus n plus minus 2 times 3 will give us 6. Give us minus 6 equal to 0. We have plus 1 plus n minus 6 equal to 0. Then making n the subject formula, we're going to have n equal to n equal to 0 log 6 minus 1 n equal to 6 minus 1 will give us 5. So the nitrogen here has the oxidation number. Nitrogen has the oxidation number of 5 in HNO3. So in order to name this compound, it's going to be hydrogen triosonitrate 5 acid. Hydrogen triosonitrate 5 acid. Remember, the 5 is coming from this, the oxidation number of this. So this is this for today. Please help me subscribe to my channel, and I'll also be showing you in the next video how to find oxidation number. For example, now I said oxidation, okay, the previous example I gave, I told you that oxidation number of potassium was plus 1. So how did I come to know about it? I will show you tricks on how to know oxidation number of a particular element. Thank you.